Welcome to Tacit Sanctuary. I don't really want to call names, but some programming languages make it really complicated to work with strings, when in fact they are nothing but arrays of characters. Let's take a look how to tackle them in Uiua. Strings are important for almost every program, no matter if we take our inputs from user entry, from command line, from text files, or from the depths of the internet. We need to be able to convert them, parse them, slice them, shape them to our needs. I encourage you to play along and try each of my examples in the playground on uiua.org/pad. You may always pause the video and experiment at your leisure. Let's have a look at characters first. In Uiua, characters are kind of special. We write a single character with the @ sign. @n is the new line. @0 is the null character. First of all, we can do some arithmetic operations on them. I can add or subtract a number to a character to transform it to another character. So the plus operator can act as a basic Caesar cipher. It's really convenient. I can also calculate the difference of two characters. I've got two examples for you where this can be useful. First, to get the position of the character in the ASCII table, just subtract the null character from it. Of course, it also works with strings. Then the operation is performed on each member of the array, and I get all the code points. Then, if I have a number as a string, I can get each individual numeric digit by subtracting the 0 character itself, without the backslash. The result is an array of numbers. Then I can, for example, take the sum of the digits. The simplest way to convert a numeric string to an actual number is using the parse function. Naturally, I can also compare two characters for equality or for smaller or greater. Now comes the fun part. Some glyphs do special effects to characters. I can use the absolute value to convert all letters to uppercase. Any special characters will be unaffected. I can switch the case between upper and lower with negation. Notice this is not the subtraction minus sign. The glyph is sort of a superscript minus, and you can type it with the backtick symbol. Using this knowledge, I will implement a sample program of my previous video in Uiua to filter the uppercase letters of a string. First, I make a copy of the string, because I will need the original. Turn all letters to uppercase, then switch them to lowercase. Now the original lowercase letters, spaces, and special characters are unaffected by this, and we only care about the letters which have changed. So using the not equal comparison, we make a Boolean mask of those letters which were previously uppercase. This masking is a very important and commonly used pattern in array programming. Now just make another copy of the string at the beginning, and then I use the keep function to filter. I ended up with just 6 characters. It's really compact code. Many of the usual array functions work on strings too. Let's try an easy one. Exercism posted this challenge, and they even made a long video listing 14 different ways to reverse a string. Well, in Uiua, the solution is so simple it's almost boring. Just a single glyph. Yes, you guessed it right. It's called reverse. These kind of array manipulating functions tend to work on any array regardless of its shape or data type. Now we can tackle the deepest mystery of life. What came first, the chicken or the egg? The egg or the chicken? The upside is that Uiua can easily handle emoji in strings. You know what? Let's decide this once and for all. Putting the chicken aside, let me show you how to do sorting in Uiua. The secret is the rise function. This is a strange one if you haven't seen it before. It will give me all the indices of the original array elements, so in this case from 0 to 5, but in the same order that would make them sorted. Rise is ascending and fall is descending order. And how exactly is this useful? Because we can then directly apply the select function to take all the elements in the specified order. And like magic, now we have a sorted list. Of course, it works exactly the same way with strings. The letters are organized alphabetically, or to be precise, according to the ASCII code points. So the moment of truth is here. The final answer to the universe and everything is the chicken is actually first. Case closed. One more problem that I can now easily solve is deciding if a string is palindrome or not. That is, it reads exactly the same in reverse direction. So first, I make a copy of the original string with duplicate function. Reverse the copy, you already know how. And finally, I need to compare. The equal operator does a comparison character by character. I could actually work with this too, but there is a better way. The match function shows us full structural equality of two arrays. Remember that 0 means false and 1 means true. So we can do palindrome with just 3 glyphs. Now let's see some useful string operations. I can, for example, take the first letter. Taking the last letter is just a tiny bit more tricky. A common idea is to reverse the string and then take the first letter. Or alternatively, I can also use the pick function with an index of -1. This is a more general solution and will work with other numbers too, as long as we remain in the array boundary. To do a substring, I can combine take and drop as required. Note that I can also use a negative number for take and drop to start counting from the end. If I want to slice the string in two and keep both parts, I can fork take and drop using the same number. This pushes both of the separated strings onto the stack. So then, how can I combine two strings? If I just want to concatenate them, I can use the join function. To insert another string or character in between, I could just push this separator on the stack, for example a white space. Then flip the last two values on the stack. Now I have the separator in the middle. And finally, join them all together. If the two parts are the same size, I could also couple them, creating an array of higher rank, in this case a 2D matrix. I can couple different size strings with a fill character. This could be white space or a dot or anything else. Then the number of columns will align to the longest word. Rather than splitting first, another option is to directly reshape the string to different dimensions. By choosing infinity for a dimension, I leave it to Uiua to use as many characters as available to fill the shape. If I pick larger dimension sizes, then the same characters can be reused from the beginning of the string even multiple times. This can create interesting patterns. Or I can also explicitly declare a fill character. If I only want a list of strings and don't care about the length of each element, then I need to put each string in a box. Suppose I have two strings on the stack. I can use the both modifier to apply the same boxing function on each string. Then I can finally join them. Notice the curly braces which marks the boxed content. In this case, it doesn't matter if I split at a different number of characters. Keep in mind that boxing can cause some performance penalties, so use with care. Another way to achieve the same result is placing the fork, take, drop operations directly inside the boxed array notation. Then the result is placed in the array immediately, and only the single array is pushed to the stack. At this point, we have the power to decide if two strings are anagrams of each other. For now, let's consider the simple case that both strings have the same number of lowercase letters. You can see a few examples here. The anagram function takes two arguments. I'm going to complete this function now. My approach is that I sort both strings alphabetically, and then compare the result. We have already done this. Select rise duplicate is the idiom for sorting. I use the both modifier to apply it to each argument, so I need to put the sorting in parentheses. And finally, use match to compare. If you are up to the challenge, you can modify this function to also work for the case when there are special characters, different numbers of white spaces, and mixed lowercase and uppercase letters. I put a link in the description to anagram.com where you can find some amazing examples. We have covered a lot of topics today, but I will probably make one more episode about strings because there is still plenty to explore. If you found this content interesting, then please give this channel some encouragement and share with me your opinion in the comments. Thanks for watching and see you next time.